We've looked at several different ways of factoring polynomials. In this lesson, we're going to look at a very special case if you're dealing with the sum or the difference of two perfect cubes. In order to factor using the sum of cubes or the difference of cubes formula, you do have to identify your perfect cubes. So we have a little table over here on the right-hand side that we can reference that has all of our perfect cubes. So let's take a look at this first example. We've got x cubed minus 343. Well, x cubed is already a perfect cube because it's x cubed. And then 343 is on my list. I know that 7 cubed is 343. So here I am dealing with the difference of two perfect cubes. So I'm going to use the formula here for the difference of two cubes. And I'm going to start by making my expression look like this: a cubed minus b cubed. So the first thing I'm going to ask myself is, what am I cubing? Well, I know that x cubed is x cubed, and I know from my table over there that 7 cubed is 343. This means that I'm going to be plugging in x for all of my a values, and I'm going to go through and plug in 7 for all of my b values. So looking at the rest of the formula, I'm going to copy this down and then plug my numbers in. I'm going to do a minus b times a squared plus ab plus b squared. And I'm going to go through, and everywhere where I see a, I'm going to plug in x, and everywhere where I see b, I'm going to plug in a 7. Here's what this will look like. A minus b, I will write x minus 7. And then a squared, that would be x squared, plus a times b would be x times 7, plus b squared, that would be 7 squared. Now, I do want to simplify this as much as I possibly can, and I see some things down there that are written not in their simplified form, so I'm going to rewrite this one more time. This would be x minus 7, and then x squared plus, we don't ever write stuff x times 7, we write it as 7x, and then 7 squared is just 49. I can actually calculate that, so I'm going to simplify it. That is my final answer. All right, here we have another one. We've got 8 plus 125x cubed. As soon as I see the x cubed, I'm starting to think about perfect cubes. So if I look over here on my chart, I do see 8. 2 cubed is 8. And I also see 125. 5 cubed is 125. So I recognize here that this is the sum of two cubes. So I'm going to be using the sum of cubes formula. And the first thing I'm going to do is I'm going to break it down to look like this. I want to know exactly what I am cubing in this expression. So we already said that 2 cubed is 8. And this one would be 5x. 5 cubed is 125, and then x cubed is x cubed. So for my formula, everywhere where I see a, I'm going to plug in a 2. And everywhere where I see b, I'm going to plug in a 5x. So I'm going to copy down the formula. A plus b times a squared minus ab plus b squared. And all I'm going to do is I'm going to go through and plug in the appropriate numbers in the appropriate place. So for a plus b, I'm going to write 2 plus 5x. And for a squared, I'm going to write 2 squared. For a times b, I'm going to write 2 times 5x. And for b squared, I'm going to write 5x squared. And I'm going to put parentheses around that because I'm squaring the whole thing. Now we need to make this a little bit cleaner, so I'm going to bring this down, 2 plus 5x. Then I'm going to do as much math over here as I can. So like I know that 2 squared is just 4. I know that 2 times 5x, I could write that as just 10x. and then 5x squared. Remember to square the whole thing. 5 squared is 25, and x squared is x squared. So that looks good, much more simplified, but I'm still looking at it and things are just not in the right order. Remember, we always want our variables to be written first in our expression and the constants to be written last. So I'm going to rewrite this one more time in the appropriate order. So instead of 2 plus 5x, that really needs to be 5x plus 2. And same thing with this second expression, that 25x squared really should be written first, and then the minus 10x, and then that positive 4 at the end. So that one took a little bit of work just to make it look the way that we wanted it to. And as you practice these, you'll be able to skip a few of those steps to write that answer a little bit quicker. All right, let's do one more. We've got 27x cubed minus 729y cubed. What stands out to me first is that you have an x cubed and you have a y cubed. So that automatically makes me start thinking about what my perfect cubes are. And if we look closely, 27 is on the list and 729 is on the list of perfect cubes. So I can absolutely use the difference of cubes formula. So like we have on the other examples, we're going to start by writing this in the way that the formula is written. So I'm going to break it down. I want to know what is it that I'm cubing here. So again, if I look over here at my table, 3 cubed is 27. So this one would be 3x cubed. 3 cubed is 27 and x cubed is x cubed. And the 729 I see down at the bottom is 9 cubed. So this one would be 9y. 9 cubed is 729 and y cubed is y cubed. So from here I have my a value and I have my b value, and I'm going to look at the rest of that formula, and everywhere where I see a, I'm going to plug in a 3x, and everywhere where I see b, I'm going to plug in a 9y. So for the first part, a minus b, I'm going to write 3x minus 9y. And then for a squared, that's going to be 3x squared, the whole thing squared, plus a times b. That would be 3x times 9y, plus b squared. That would be 9y squared. Now simplify that because that second half is a little messy. So let's bring this down. 3x minus 9y. Now if you actually square this part here, 3 squared is 9 and x squared is x squared. So 9x squared. And in the middle, 3x times 9y would be 27xy. And in that last part, if you square it, make sure you square the whole thing. 9 squared is 81y squared. And that would be our final answer.